So hello everyone, hello Nullcon. It's 6:19 here in Poland and Hungary, so I think it's a good time to start. So yeah, today we're gonna talk about exploiting XPC in antivirus software. Csaba, if you could give me a control of the screen. Yes, I'm now controlling it. So my name is Wojciech Reguła, and I am a senior IT security consultant at SecurityFest. I mostly focused on application security of iOS and macOS. Also, in my free time, I run an Apple Info Security blog, so you can see the link on the slide. And you may also me from my side project called iOS Security Suite, that is a free and open source Swift library created for developers to help them secure their applications on iPhones and iPads. So, Csaba.
Thank you, Wojciech. My name is Csaba Fitzl. I'm right now a content developer at Offensive Security. I'm part of a team who creates new training material for the company. I used to be a red and blue teamer in a large enterprise before that. And in the last 2 years, I've been focusing on macOS research and security. I have 2 kids and I'm married, and I love to do hiking and yoga in my free time. Thank you. Back to you.
All right. So in this talk, we'll at first introduce you to macOS inter-process communication because it's kind of complicated. Then we share our research, the results. Then the typical issues, and I think the most sexy part of the talk, so demos and vulnerabilities, along with the working exploits. And because we don't like leaving people without the fear and lack of recommendations, we'd like to share with you recommendations as well as for developers, as for users. And then Csaba will show you the future regarding the XPC. So this is the interesting story because we both separately started 2 different XPC researches in 2019. Then we had 2 different talks completely separately. We didn't know about each other's plans. And as you can see, 2 different slides on different conferences. And when we saw each other presentations, we decided to team up. So here we have, this is the result of our first joint research. But before talking about XPC, I'd like to introduce you to macOS inter-process communication in general. So as you can see on the diagram, there are a lot of IPC in macOS. It's even called a zoo. So most of the popular inter-process mechanisms are based on Mac messages, and you can see MIG, distributed notifications, XPC, and on top of that NS XPC. And as you can see, almost all of this zoo goes through the Mac messages. So in order to understand how to exploit XPC, we at first need to understand how does the Mac messages work. So Mac messages are really, really fundamental for macOS. You can think about them as a kind of POSIX pipes. Because they are similar, we can have only 1 receiver and possible multiple senders. They are really powerful because they allow us to send messages with data, but even memory or another port pointing to another XPC, to another Mac server. And what's important with the Mac messages is that the sent messages are placed in a message queue whenever the Mac server is not able to handle them in the same time. So please keep it in mind, because it will be required to understand further exploits, the enqueuing the messages. So XPC is built on top of Mac messages. It's a not really convenient API because it's written in C. So it's a dictionary-based communication, strongly typed, with strings, booleans, dates, etc. And then the NSXPC, the most convenient API, because you can call it from Objective-C or even Swift. You call remote methods on the other side of the XPC because it's inter-process communication mechanism, right? So these objects have to conform Objective-C or Swift protocols. And in my opinion, the most convenient thing regarding NSXPC is that you can even send the serialized Swift objects. So you can make such a communication almost transparent even to developers, because you just call some Swift methods. All right, so now the statistics, the results of our research. So our sample were 28 different antivirus software. And the important thing here is that we only tested those we had access to. We didn't have access to every possible antivirus in macOS because some of them are closed and not easily accessible. So please keep it in mind. And first half of the tested antiviruses used XPC. And the second half, equal half, as you can see, mostly used sockets or Mac messages. So yeah, we have only assessed this XPC antiviruses. So this research is still open. If you'd like to assess the second part of the antiviruses, the Mac messages part, or mostly sockets, feel free. It's still open and ready to be assessed. And the chart, as you can see, again, equal halves. The first half were antiviruses that were using XPC were vulnerable, and the second half is the antiviruses that didn't use XPC at all. So I think it's now really easy to deduce that all the antiviruses that used XPC were vulnerable. And it was really shocking to us when we conducted this research, because all of these antiviruses that we had access to were vulnerable in their XPC validation mechanisms. So the typical issues. I'll quickly show you the attack techniques that we identified regarding the XPC bypasses. So the 4 main techniques, I'll try to elaborate them. But before, let's see the 3 main components that I will be showing during the next slides. So the most important thing here is that only the first one, the privileged XPC server, is running as root. All other components will be run as user. So we'll try to elevate our privileges by exploiting the privileged XPC running as root server. So the first attack scenario, no validation in XPC server. So our malicious application running as user asks the privileged XPC server to perform some actions for us. And because it's no validation, no client validation vulnerability, the server says, yeah, okay, I won't even verify you. So it's directly or indirectly leading to local privilege escalations attacks, right? Because our unprivileged component asks to perform some action in the context of the privileged running as root component. The second attack scenario, our malicious application cannot directly talk to the XPC server because there is some kind of cryptographical validation. So we have to init the connection from the trusted executable. So the technique here is to inject a malicious code to the completely legit XPC client running as a user that will call the remote methods on the server. The server will perform the cryptographic validation. It will of course succeed. It will of course succeed because it's a trusted client. And again, the privileged method will be called for us. Okay. And the third technique. So before macOS Catalina, it was really common that the applications were vulnerable to code injection attacks. Hardened runtime was not mandatory because there was no mandatory mechanism called notarization. So it was pretty easy to inject our malicious code to the applications before macOS Catalina. But when notarization became mandatory, almost all of the applications introduced the hardened runtime. So we now cannot easily, in most cases, inject our malicious code. So how we work around this? Oh. Csaba, I'm clicking. Oh, yeah. So we decided to inject to an old versions of the XPC clients, and because these clients were developed before macOS Catalina, the code injection was possible. So even on the newest, for example, macOS Big Sur, it's still possible to inject to them because they didn't implement the hardened runtime. But what it gives to us? In macOS, the cryptographic validation is mostly based on sec requirements that are, as you can see on the slide, simple strings. And these simple strings usually contain the following information: that the executable has to be signed with a certificate that was issued by Apple that gives us this unsure Apple generic. The bundle identifier of the application must match. And the last one, that the certificate has to have the proper team identifier. And as you can see, in most cases, you don't change your developer certificate really frequently. So the sec requirement was and is the same for the new version of the XPC client as like for the old version of the XPC clients. So this attack scenario is really similar to the second one, because we again inject a malicious code, but here to the older version of the XPC clients that will call the remote methods on the XPC server. And yeah, it will be completely legit because the validation is based on the sec requirement strings that remain the same across the versions. And the last technique that we wanted to show you for today is that quick reminder. When we have our malicious application, the server performs the cryptographic validation. Of course, if we try to connect to that server, our signature doesn't meet the requirements, so the connection will be quickly invalidated, right? But what if? What if our malicious application forks a lot of times, like hundreds of times, and each of this each of these children tries to connect to the XPC server? And as I told you on the beginning of this presentation, XPC is based on Mac messages. And it's now pretty understandable that this server won't be able to handle all of this connection in the very same time. So they will be enqueued. Server has to put this connection on a queue, and it's made transparently by the operating system. So let's see how this queue look like. I'm getting, so this queue, as you can see, each element of that queue has a connection, process identifier, and the action to perform. Of course, the XPC server will pop each element from the queue and verify the client based on PID. And if the validation succeeded, the action is performed. The next slide. Okay, so but what if in the same time, if the queue is full, the malicious applications that just try to connect to the XPC server call POSIX spawn. It's a function that allows us to replace the process bits to the legit one, to the legit bits of the legit client. But in the same time, the process identifier remains the same. Okay. So let's take a look on the validation. So if the validation is based on the process identifier, we create a code object based on it, perform a signature check, and verify if it's valid or not. If the bytes are valid, we establish the connection. If they are not valid, we of course invalidate. Okay, the next slide. All right, so it may lead to such a situation where some of the connections have been invalidated, but in the same time, our application did change its bytes before the actual validation. So it may lead now to a situation where I'm sorry, I cannot swap the slides. If you could, Csaba, once again, yes, turn it on, because we're using the shared screen and I have some technical difficulties. I'm clicking the right arrow, but the slides are not going further. All right.
I just moved the slides for you.
Okay, thank you. So it may lead to such a race condition attack where our malicious application swapped its bytes. The validation is performed on the legit client, but the action was enqueued before the swap. So in the end, our malicious action is performed again in the context of the privileged XPC server. So now the shell time, the vulnerabilities that we have found. So the first one, MacKeeper. We identified multiple issues like using the vulnerable process identifiers or missing the client hardening validation. You can see the code on the right side of the slide that there is a call to process identifier. And the sec requirement string only contains the certificate information without any version check or anything additional. So we have decided to inject to the old MacKeeper client. But how did we reach local privilege escalation? So MacKeeper exposed many NSXPC methods. And one of these methods were initialized with OpenVPN path. And as you probably guessed, the OpenVPN is a type of VPN. So it redirects all the outgoing traffic from your computer. So for that, of course, it needs to be privileged. It needs root permissions. So we tried the scenario, what if we call the initialize with OpenVPN path method, but pointing to the malicious executable. As it turned out, MacKeeper didn't validate the executable that we were pointing to because it performed the validation on the XPC level. So as you can see in the bottom of the slide, our malicious open VPN client that just writes the privilege elevated to root string to etclp, and then we called the two XPC methods. So at first we initialized with open VPN path and then started the connection. And now you can see the demo. Oh, really good, Csaba launch it. Yeah, so the etclp file is not present, but now let's try to exploit it. And now, as you can see, the etclp file is present. That means that we have achieved the local privilege escalation. All right. So Intego Mac Security, another vulnerable antivirus. It again had multiple issues, like using the process identifiers or missed the client hardening validation. And again, we've decided to go the easiest way, that is injecting to the old Intego installer. So Intego used over 10 different XPC services, so there were a lot of different methods. But we have chosen this example to show you that by exploiting XPC doesn't mean you always reach the local privilege escalation in terms of achieving root privileges. Sometimes it allows us to break the business logic of applications, because we can only exploit these methods that were exposed, right, by XPC. In this case, we are talking about an antivirus software. Via XPC, it allowed, for example, to set the global protection. So we have abused it, and it allowed us to completely disable the antivirus from totally not privileged application. Let's see the demo. As you can see, the net barrier protection is turned on, but now we launch the exploit. And again, as you can see, we have successfully exploited the XPC. The protection is now off. And the last example from my half of this presentation, Avast and AVG. I treat them as one case because Avast bought AVG and they share the shared XPC code base. So the issue here was missing the client hardening validation. And again, we've decided to inject to the old version of Avast. And this is yet another example of XPC exploitation, but in this time we wanted to show you that sometimes the applications perform an additional validation. So by bypassing XPC, it doesn't mean you in all times exploit it without any other authorization. In this case, the Avast and AVG raise a pop-up when user has to authenticate, but it's a completely legit pop-up launched by the legit antivirus, right? So macOS users are used to pop-ups and they will likely provide their credentials. Let's see how it worked in the demo. Oh, Csaba, if you could, we probably clicked twice. Okay, so as you can see, the pop-up is raised. We provide our credentials. And then the core shields are turned off. So it's everything from my side in this presentation. I'm giving the microphone back to Csaba. Thank you.
Thank you, Wojciech. So the next one on the line is F-Secure. I think this was one of the first AVs we assessed. It might be even back in end of 2019. Again, the very same issues that we showed with the other clients or other AVs. First, it's missing a client hardening validation. So again, it only checked the team ID if it's signed by Apple and the bundle ID. So again, it allowed us to use an old client with F-Secure. And it also used the process ID for the validation. So that was another part, and F-Secure treated it as two separate issues. So we used an old client for the exploitation, but similar to Avast, here we also had an obstacle that F-Secure used authorization for all of the sensitive or higher privilege action run by the XPC server. And it was tied back to the system.privilege.admin authorization right on macOS, which you can only get if you are either root or you authenticate yourself as an admin user. So again, the user will be created with a pop-up, but as we show here at the bottom right corner of the screen, this is the pop-up you would see. So it's completely legit. It's really coming from F-Secure because we are injecting into that application. And again, macOS users, we believe, used to these pop-ups, and we just freely authenticate. The next AV, ClamXAV, it's a small AV, small company. This was, I think, one of the best vendors to work with. They were really fast to respond and really fast to actually fix the issues. And again, the very same problems, missing client hardening validation and using the process ID. Probably by now you get used to this pattern of issues. It's really repeating and coming back. So again, as you can see, the sec requirement string they used is be signed by Apple and have the same team ID. So for the attack, we could just download their old client, client version 2, which didn't have any hardening, and we could just inject ourselves now. This AV actually, we were able to get full privilege escalation with this. The privilege helper tool offered very useful functions. One of them is trash file, which allow you to delete any file, and the other one is move file, which allow you to move one file from one place to another as root, which is basically a trivial privilege escalation scenario, probably on any operating system, including macOS. So what we choose here is we move the plist launchd startup file into launch daemons. So whenever you reboot the computer, whatever is defined in that plist file will be launched as root. There are many other options, updating periodic scripts or installing a PEM plugin. We just picked this one. And furthermore, the privilege helper tool allowed full control over the AV through the right settings. So basically this exploit was not just a full LP, but also a full business logic compromise. So here's the demo of this. You can see that the library launch daemon folder only contains ClamXAV, normal launchd files, and one from VMware. And now if we launch our attack, we inject a dilib through environment variables. And yeah, this is the old client popping up. We can kill that. And now if we list the directory again, you can see that we have a new plist file showing up on library launch daemon. The next AV is Acronis. Here they have only one issue, is again missing client hardening validation. So again, we could use an old client with the AV. We use the 2020 version of the client to escalate privileges on the 2021 version. Their privilege helper tool was very good in terms of for us to do privilege escalation. They offer an execute process method through XPC, which it does exactly what it sounds. It will execute a process, and since it's running as root, it will execute it as root. It even allowed us to specify arguments or environment variables if we wanted. So here's the demo of the exploit. So you can see we have our dilibs prepared, what we want to inject into the old application. We have the old application right there, the Acronis true image app. Let's just check its signature, why it's vulnerable, why the old client is vulnerable. So although it's signed with hardened runtime, it has the disable library validation, and it allows deval the environment variables, which makes it really convenient to inject any dilib into the application. So we can again just use the deval the insert libraries environment variables for injection. And we start the app. So since we run it for the very first time, actually, the old client gatekeeper did some verification, and because of that, we rerun the exploit. And now you see a terminal coming up, a new terminal, and it runs as root. So basically what we did here is executing terminal as root through the privilege helper. So these bugs are all fixed. At this point, we couldn't reveal all of the bugs we found because some of them are still being fixed by the vendors. So let's see what are our recommendations for developers. First of all, so we need to split XPC into two parts. The first half is the client, and the second is the XPC server. The client side is easier, probably. You just need to sign it with hardened runtime and or library validation. But since that these days macOS mandates notarization where hardened runtime is mandatory, probably this is an easy step. And the second thing is that these entitlements, COM Apple security, disable library validation, and get task allow, must not be present on your client, because if any of those are there, someone can inject code into the application. If the disable library validation present, then someone can inject the dilib, and if the get task allow present, then someone can inject a shell code through Mac task ports. The first one, the library validation, can be problematic if you need to support third-party plugins. And also, your probably shouldn't have any script files, at least not script files that you run, that you load into your application as unsigned code like JavaScript or something. This is especially important in case of like Electron-based applications, because the signature of script files or the hash is not verified by the OS when you start an application. So you need to do it yourself if you need to support this type of files. The server side. So if you use the NSXPC framework for XPC communication, then there is the should accept new connection method, which is basically handling all of the incoming connection. And this is where you decide if an incoming connection is accepted or not. If you use the old C XPC API, then the connection handler can do the same verification, basically. So the first one is, it's very important that you must verify that the connecting client has a cert that is signed by Apple. Second, the connecting process must be signed by your team ID. Third, now you probably also need to check if you the bundle ID of the connecting client. Although if you only have a single application, it's not a hard requirement, but if you support multiple applications, this is a good practice. And the last one here, you can take two parts. One is you can check the code signing information of the client during runtime. So you can check if it's signed with hardened runtime or if it's signed with library validation. And if so, then you need also check if they possess any of the entitlements that make them vulnerable, like the get task allow and the disable library validation. What you can also do here is, if you know, let's say that your client version 10 is hardened and is properly fixed and no one can inject any code into your version 10 client, you can verify the software version of the connecting client and say, I only allow clients above version 10. So basically this mitigates the issue where we can use an old, let's say, version 7 of the client and connect to the XPC service. Likely the first way is more scalable in the long run, but basically both of them is a good way to do it. And to mitigate the process ID attacks, someone must use audit tokens to identify the client. Now, the issue here is that the audit token API is private to Apple, and it's not a public API. You can still use it with a few tricks in your code, so it's not impossible, but it poses a problem, especially if you want to publish your software in the Mac App Store, where you are not allowed to use private API. But if you are a developer, please reach out to Apple and tell them that you need this API to be public. We did it as well, and we know some developers did it as well, yet it's still private. So we hope Apple will listen one day. Wojciech made a simple XPC app, which is demonstrating how to do XPC in a secure way. So it has all the right checks, and if you are a developer, we highly recommend checking this out. And I really like what Casey said in the keynote, that the next step of bug bounty is providing a fix for the vendor or a way, or demonstrate how it can be done securely. And basically this is what we try to do here. This is a really widespread problem, not just for antivirus software, but everything else. Recommendations for the users. Well, we know that this will take a long time to get fixed by many of these vendors and get it securely every time. We have an application called Shield, which I made using Apple's endpoint security framework. What it does is tries to mitigate all of the injection attacks we discussed here. So this is not targeting XPC specifically, but blocking injections. And because all of our XPC attacks, or most of them, I would say, not all, but most, are based on injection, this tool can easily mitigate many of the exploits we demonstrated. And it's also available from GitHub. One note is that some injections can be used in a legit way. So you need to sometimes turn it off, especially if you are a developer and try to debug application. Then the task for PID injection, for example, is done in a legit way. So here is the ClamXAV demo again, but now with Shield running in the background. So we try to do the injection again, and you see there is a pop-up from Shield that the injection was blocked. And if we check the launch daemon folder again, we can see that there was no new plist showing up, so the privileged escalation was mitigated. And lastly, the future. How we see the future of XPC and all these bugs and everything. Unfortunately, it's dark at this point, and there are many reasons to this. The very first one is there is no secure public API from Apple, what we mentioned earlier. Second, Apple's sample code for XPC, all of it is insecure. So when people start to learn, developers start to learn XPC and how to do it, they will like turn to Apple's sample code, implement that, and that will be insecure. And we actually saw applications took Apple's code as is and used that. The next thing is many antivirus vendors used kernel extensions in the past. Now they won't work beyond Big Sur, or even if they do still, because they are not using those API that were deprecated, soon the rest will be likely deprecated as well, and they will have to move to the new way of developing security software, which is system extensions, SEXT. That is what is supported now by Apple, and with using SEXT, the IPC recommendation from Apple is to use XPC. On the kernel extension, there were other ways to do IPC, not really XPC. And again, the problem here that what Apple provides for the system extension sample code XPC, that's not secure as well. And likely these vendors, these AV vendors, will not have any XPC experience, or likely won't have. And because of the previous, they will likely implement it in an insecure way. And this will bring in a whole lot of new vulnerabilities in these AVs. So we hope they watch this talk and learn from others' mistake and will implement XPC in a secure way. If you are doing bug bounties, then yes, vulnerabilities are cool. Like you can earn money with that, but also it's bad for the overall users, as there will be issues. out there. Some further resources, if you want to dive into XPC and XPC exploitation, this is a list of talks from other previous security conferences talking about XPC. As you can see, the very first one came from Jan Beer back in 2015. We are in 2021, and this is still a thing. That was it from both of us. Thank you for listening, and let us know if there are any questions.
Thank you, Csaba and Wojciech, for this interesting presentation.